Key terms, Chapter 8. Quadratic regression model, nonlinear regression function, polynomial regression model, cubic regression model, elasticity, exponential function, natural logarithm, linear log model, log linear model, log model, interaction term, interacted regressor, interaction regression model, nonlinear least squares, nonlinear least squares estimators. Review the concepts. 8.1 sketch. A regression function that is increasing, has a positive slope, and is steep for small values of big X, but less steep for large values of big X. Explain how you would specify a nonlinear regression model to model this shape. Can you think of an economic relationship with a shape like this? Answer 8.1. The regression function will look like the quadratic regression in figure 8.3 or the logarithmic function in figure 8.4. The first of these is specified as the regression of big Y onto big X and big X squared, and the second as the regression of big Y onto the natural log of big X. There are many economic relations with this shape. For example, this shape might represent the decreasing marginal productivity of labor in a production function. Review 8.2. A Cobb-Douglas production function relates production Q to factors of production capital, which is K, and labor, which is L, and raw materials, which is M. These are capitals, and an error term using U. Using the equation big Q equals lambda big K to the power beta sub 1, big L to the power beta sub 2, and big M to the power beta sub 3, and E to the power U, where lambda, beta sub 1, beta sub 2, and beta sub 3 are production parameters. Suppose you have data on production and the factors of production from a random sample of firms with the same Cobb-Douglas production function. How would you use regression analysis to estimate the production parameters? Answer 8.2. Taking logarithms of both sides of the equation yields the natural log of big Q equals beta sub naught plus beta sub 1, the natural log of big K, plus beta sub 2, the natural log of big L, plus beta sub 3, the natural log of big M, plus U, where beta sub naught equals the natural log of lambda. The production function parameters can be estimated by regressing the logarithm of production on the logarithms of capital, labor, and raw materials.